water column where oxygen is at its lowest. That oxygen minimum zone is expanding in the vertical plane. As the water gets warmer, as it becomes more acidic, oxygen is less able to be held by the seawater. And that expanding oxygen minimum zone is having a pronounced influence on the animals that live out there. This is the little shrimp, Sergestes similis, very common, quite abundant, as a matter of fact. It's food for salmon and tuna and a wide range of other animals, many of them commercially important. It's fodder for a great many animals. Now, in a 5-year period, we measured the top of the oxygen minimum zone that's getting closer and closer to the surface every year. The red line shows the expansion, the shoaling of the oxygen minimum zone. And at the same time, we plotted the daytime depth, the center of occurrence of Sergestes similis. And it has shifted upward as well. There's a strong correlation between the reduction of oxygen in the water and the change in depth of this species. Now, that's a correlation, but we can't say for sure that that's what's causing, the expanding oxygen minimum zone is what's causing Sergestes to rise. So the engineers at MBARI developed an instrument that allows us to measure the oxygen requirements of these animals. In the past, we would drag nets behind ships, bring the animals up to the surface, put them in a respirometer, and measure their oxygen consumption rates. But those are animals that had gone through decompression and thermal stress. So our engineers built us an in situ respirometer, 8 chambers here, that we can fly down in the ROV, collect animals in each of the chambers, have 1 or 2 for controls, and then fly over to a mooring, decouple hydraulically, electronically, and mechanically, and let the respirometer incubate in situ. So the animals don't have any decompression, they have no thermal stress. We typically fly around, check out to make sure everything's looking good, and then we go away for 24 or 48 hours. Fly back, reconnect with the respirometer, bring it back to the surface with the ROV, and invariably the animals are still alive. So we're getting a much more reliable picture of their oxygen consumption. And in the oxygen requirements of any species, whether it's us or Sergestes, you can regulate oxygen down to a certain low point of oxygen availability. And once you get to that point, and it's different for each species, you can no longer regulate, and you have to compensate, which means either moving to where there's more oxygen, or going to anaerobic metabolism, or some other trick like that. What we're hoping to do is to determine the critical point for Sergestes, which we've done, and couple that with the change in depth to show something that's much more like a causal relationship between oxygen requirements and the shift upwards in its depth range.